Okay, so now we're getting into the code. The first thing we're going to do to make this happen is that we want to get some type of API like this init should run update and render in our game dot Odin situation. And what we want to do then is have some type of, we want to have some type of other main file that just kind of very simply orchestrates this top level game loop happening. Then what we're going to do after that is build this to a game.dll. And then instead of, in this situation I was talking about, that would essentially be like an in-source library module usage. What we're then going to do is build this into a game.odin and then have the very basics of our hot reload manager app just using game.dll as a DLL, running it simply. Then what we're going to do after that is add the code to facilitate swapping between game DLLs. Okay, so let's do that first step. Okay, so in our main, we have some initialization stuff. We have the should close or the should run condition. And then we have what we're doing each iteration through that loop. So first thing we'll do is we'll do an update and render proc, okay? And then I believe this, trying to remember the shortcut to highlight everything in a scope, but I forget, so we're just gonna do this for now. So we pasted that all in the update and render function, so I am just going to do that and build it. Okay, so getting an issue now because this is, some of this stuff was in the main function scope. All I'm going to do, I'm going to take that out of there. And for right now, I'm just going to put it here in the global scope. But don't worry, we won't have this, we won't have all of these out here in this file soon. And you'll see what we're going to do. So let's build that. Okay, and let's just get that to run. Okay, great. It's still running. Then what we're going to do is have this data being specified in an init function. So init proc, boom, boom. Going to copy all this stuff. Oops, I said copy, not cut. We're going to do that in there. Over one. And then I'm just going to turn all of these walruses into an equal sign. Oh yeah, if you, I found out, I think it was the Python people that started calling this the walrus operator. I quite like it because I kind of see how it looks like a walrus. So we will do that. We'll set it in there, and then we'll just make this up here for specifying the types of stuff. And you'll see why we're doing it like this soon enough. This is a bool. Okay, and then we also want to init the window in the init. So we're going to build that, and then we are going to run it. Oops, it is shutting off. Oh, well, we need to call the init function up here, build it. Okay, great. And then last but not least, we want to make that should run function. So for should run. Okay, so this is what our loop ends up being like. And let's just go to, oops, toggle that again, build it, run it. Okay, great, it's still working. So now what I'm going to do is I'm going to separate this game. So now what I'm going to do is separate this game file off into its own, oops, I'm going to separate it off, come on, into its own little folder. There we go. And then I'm going to make a new one. How do you make a new folder like this? Okay. And I'm just going to call this main default. Also, I should mention that a lot of these ideas of how I'm doing this come from Carl Zielinski's posts and video about hot reloading and how he set it up for his Odin project. So if you hate my explanation of it and me showing this, check out his because it is probably a lot better. So then what we'll do is make this guy. I'm going to copy all this stuff, copy, let me close that out because we moved it. And then in here, I'm going to make this package main default. And then what I'm actually going to do is import the game from .game. And I'm going to put this in here and just call it main. That's all I'm going to do. And then for all of these guys, I'm going to do game.init, game.shouldRun, and game.update and render. So now, this one, where's the main? I'm going to get rid of the main here. And then in here, what I'm going to do is change the build script to instead build source main default, and then build it again, and then let's run it. And okay, we're working. And if you missed it, what's happening now is that we have this main default that we will use for like normal builds of our game, whether it's debug or whether it's a release or something like that. For right now. And then we've made it so our game exposes some source code level functions that you could use. So now what I am going to do is make another main for hot reloading. We're going to come here and let me copy this and then put it in here, and then we'll change this to main hot reload. And the first thing, like I said, we're going to do in here is just get it so we're consuming a game DLL and using that instead of right here, which would be the in-source version of that library. So let me get rid of that. Let me save it, and this will go in here. So we'll just call that main as well. Okay? And what I'm going to do is I'm going to start specifying that game API struct, okay? And it's going to have an init function. So that will be a proc. Then we're going to have a should run function. There'll be a proc that returns a boolean. And then we will have an update and render proc. That won't return anything. And the idea is we will have a game API, and then this will get called like so. And notice this isn't specifying any type of implementation. These are going to be filled by something. So what we're going to do here is we are going to import the dynamic library that Odin has, that is cross-platforms and should work on Windows and the Unixes, Mac, or at least like Linux and Mac. And I think there is some different behavior that happens depending on what platform, but it wraps them, which maybe we'll look at that. But essentially what we're going to do is we're going to call the game API, well, we're not going to call game API, we're going to set it equal to the dyn_lib and initialize symbols, and what it takes in is this symbol table of like any particular type. And the idea is that this type should have, doesn't have to, but it will likely have some functions named to be the same functions that you're exposing. But if we go in here, what we're kind of working here is that we have a handled field name, and it's going to check for that API struct that you're passing in, that it has a field name where it could store a handle to the actual dynamic library object that is going to get created some here. And this is the default one it's looking for here. So I am just going to set it to that. And it's Raylib. Is it, what is it? Let me see. So the name field pointer, I think it might just be a raw pointer that we get at the end of the day. So I am going to set it to that and see what happens eventually, because that might be wrong. So what we're actually going to do here is pass in this game API, the library path. So we will want to have somewhere, and I think I am going to start to make a build directory to store some of the build stuff, and a hot reload subdirectory where only the hot reload stuff is going to go. And we're going to have a game.dll. And we don't have a symbol prefix. So like that's like if there's a C library, a lot of the times the functions will be prefixed with the library name or something like that. And what it returns is, I think, the number of symbols that it got out of there. And it returns if the load was okay. Okay, so what we're also going to have to do here before we build this dynamic library is specify what functions we're actually exporting here. So you use this little notation here to say these are the things that I want exported. Okay, so now what we actually have to do is build this library and then read it into here. So let's do that. So make a new one. First thing we're going to do is turn the echo off and then save this as, we'll save this as build hot reload.bat. Okay. And what we're going to do is if not exist build make dir build. And I think let's actually see if it works like this. If I could just say hot reload, or if it wants me to build these separately, I forget. And then I'm also actually, I am just going to put them in two separate things now and kind of concatenate them. So out dir equals build / hot. Cool. So yeah, let me do that. So build dir. Okay. So what we're going to do is we're going to build those directories if they don't exist. And then we will set the exe. Actually, what we want to do now is just build the DLL. So let's do that. So Odin build source game. It's going to be debug. And then what we're going to do is we're just going to define Raylib shared to be true. so that we use the dynamic linked library version of Raylib instead of using the static linked library, because we don't want the Raylib memory to get unloaded if we unload our game. So then we're going to set the build mode for game to DLL instead of executable, so that this will build a DLL for us. And then we're going to call it game.dll. And then we're going to specify, yeah, that's what we'll do for now. So we're going to build that, and then if, okay. So after we build the DLL, then what we want to do is build the main hot reload package out. And actually, I forgot that we want these in the outer game.dll. And then we want this to also be in the outer. And we want this to be called hot reload.exe. Okay, so what this is going to do is it's going to build our game as a DLL, and then it's going to build the hot reload manager exe. And because in here we do this, and so long as this path is good, I think those will get loaded okay, but we'll see. Maybe we made a mistake. And then I also want to set this error level there. And the last thing we have to do is get the Raylib DLL we want to get it into the output directory. So let's do that. So we want to get the path of Odin. So Odin will keep. So if I go to my Odin install, and we go to vendor, and we go to Raylib, and we go to Windows, we see that Raylib keeps, or in Odin, it keeps the Raylib DLLs in here for you. And because we're dealing with the situation where now Raylib is dynamic linked instead of static linked, we need to, at least on Windows, make sure that this is in the same directory that our executable is, so that the executable could find it, or sorry, the game DLL could find it. So Odin has a command called Odin root do set Odin path equal to that, and this should actually be not here. So Odin has an Odin root command, and let's just see what that does. Odin root. So that just prints out where your Odin install is, if Odin has been set up on your path. All right, so now what we're going to do is get Raylib in there. So if exists, and we're just going to check if it exists first. Actually, let's just copy it. So copy Odin path, vendor, Raylib, Windows. So this will be different if you're on a different platform. Raylib, and then we're just going to copy it into the out directory. Then also do this. Okay, So we're going to copy Raylib over, and let me just like run this so we could see what is going on here. So build, and I might get some issues here, so we'll see. Okay, so now where are we? Tetris edu. Oh crap, that was not what I wanted at all. Oh, my mistake was that those actually got made. Oh, but oh wait. My mistake. And let me actually get rid of some stuff here, because that stuff that was stuff I was messing with before. That I don't think that was the result of the script. But let's try again. LVM message file 33. Okay, so let's do this. So essentially, I just wasn't referencing these as variables. I think that's what the problem was. Okay, and let's see. Oh, let's make it like that. I like that better. Okay. So what do we get in here? We get the game DLL. We get the hotreload.exe, and we get the PDBs, which are the debug databases for the debugger, and we moved the Raylib.dll in here. So I was like way off when I was like showing my hypotheticals earlier, and I was like, oh, it's 100 megabytes. Like it is nowhere close to 100 megabytes. I don't know where I was getting that number from. All right, so what we want to do now is first let me get rid of that garbage. Boom, boom. Okay, so let's try running the hot reload executable from here. So build hot reload.exe. Hot reload, oh, because it's in the hot reload directory. Okay, so it's working as far as I know. Let me just make this like garbage just to see if it fails, to make sure I'm not crazy. Or sorry, let me just make sure I'm not incorrect. Okay, so now it won't run, I'm pretty sure, because this is failing here. And I will do it again. All right, awesome. So what we've seen here is essentially a way that we could load this game.dll's implementation into these function pointers here. And what I want to do now is do that hot reloading trick. I mean, that's why we're here. So what we will have to do is a few things, because it gets a little tricky. It's not super complex, but there will be a few moving parts. So there's a few things we have to do now. Let me just write a to-do list here. So what we now have to do, and this is like, so because if this DLL is being used, or I don't even know why I was highlighting that, like if the DLL generated here is being used by a program, we can't necessarily write to it. So we need to have multiple game.dlls. So have some way to differentiate between DLLs are actually have some way to differentiate between DLLs, and we'll just say like the old versus the new one. And then so that's one thing we want. One other thing we want is that PDBs, we also want to differentiate between PDBs. And that is because debuggers will also typically lock the PDBs, and we need some way to say that this PDB corresponds to DLL. So if we have like a DLL1, we need, and this is more like exactly how it's going to be, but we would need a PDB1 to go with it. And then if we have DLL2, we need PDB2 to go with it, I think. And what that will mean is that when we are building this, we will specify, say, like PDB1 or PDB2 or something, because the DLL will contain information about the path of the specific PDB that it was given. So one other thing we'll need to do is that if our executable is running, we don't so if it's running, we don't want to build the hot reload manager app again, only the game DL. Also, if it's not running, so else, we want to essentially like clear the build hot reload directory, maybe. We'll see. All right, so let's do that. And then in our code, what we'll also want to do is load Raylib outside of game stuff. So inside hot reload manager app. All right, so I think the first thing we'll do is that if it's running, we don't build it again, and then we'll test that. So let's set game running to false. And then how we'll do that is for so what we're going to do is we're just going to look in the task list for our game. So image name equal so equal so set exe equals 2. Just set it to hot reload.exe. And we'll also do that here. So exe. Okay. And then if image name equals to that, do if game running to true. So this will basically go over the task list and then tell us if the game is running or not. So if game running equals false, then we want to run that stuff. Okay, so what I'm gonna do is now try running this. So build dot hot reload dot bat. Okay, it built. And then what I'm gonna do is I'm gonna run it. So kind of have to run it from here. So let me open up my command here because I forgot how to open up multiple terminals. So what we're going to do from here is do the build hot reload and then hot reload.exe. Okay, so now what I'm going to do is maybe an else here. Could I do that? Else. And then echo let's just say this for now. Save. We'll try already running that. Oops, it's not showing. So I think what we're actually going to do is build to this DLL right here. And then what we will do in the main.hot reload is copy the DLL to a specific, a different DLL, if that makes sense. So the game will basically copy that into its own to use. Don't know if that makes sense, but hopefully after I show it, it will. I think os2, and then that would be like os2.copy file. And the destination path, let's just call build hot reload game.dll dot I'm trying to think, because if we name this and then it does it, it can't necessarily copy into it again if we need to replace it. So what we will do for now is what Carl Zielinski does, and we will have a version number in the game API. And what we're going to do is we're going to copy the game.dll that was built into a different file that contains this version number. The reason we'll do that is because our game.dll won't be too big. So it's not going to like take up a crazy amount of space. And what we'll do is that if we are building from scratch again, we'll just clear out the folder so we could start fresh. So what I'm going to do here is have the path to that, or the DLL dir is, so import core.format actually what we'll just do is plus the DLL name plus underscore, and then we will fill in the game API version there. And then we'll print that to the copy DLL file name. Okay, great. And then what we will do is that this is the dest. So the dest, actually let's just say dest DLL file name. So dest DLL file name. And then the source will be the source full DLL file name. Then I think we could just set it to plus DLL.txt. source DLL file name. So I should copy it over, and then what we want to do is use the dest DLL file name. And let's just see, what does this return? So it returns an error. So let's just say copy error. If copy, just a little something to see. Just a little something to see. So it'd be the dest DLL file name and then the copy error. Okay. And then the dest DLL file name. So let's see if that correctly builds now. So let me stop running this. Let me build hot reload. And did that work correctly? System working. Let me delete build, actually come here. Let me just delete all this stuff. Run that again. And let's see if that gets built. So yes, it built the hot reload exe. So let me run it here. Okay, not exist. Oops. Huh. Okay. Totally, these should not be strings like that. They are variables. And let me actually set up my build system tool. Build system, the hot reload. And then let me make it build hot reload.bat. So if I build that, okay. And now let's see. Okay, so now we're working. And let's see down here. If I could build that again now. Okay, so at least it runs again. And let's see if it built the game.dll. So, okay, and yes, it looks like the game_0 has been built, which that 0 is getting from this version right here. Okay, so now what we want to do is if the DLL contents change, we want to load it in again. So we'll do import core OS. And if you're using a newer version of Odin, the OS package should be integrated into this OS. But if we're using something earlier than the March 2026 build, they'll be split into OS and OS2, where OS2 is essentially intended to be a rewrite of some issues that the OS library had. Okay, so what we want to do in here is we want to store the version and the modification time. Or yes, we will want to store the modification time. And that will be, what even will that be? I think it'll just be an int. Actually, sorry, it'll be an OS file time. So what we're going to do is we're going to set the game API modification time equal to OS get. Actually, we're just going to set modification time equal to OS dot modify. So to OS dot last write time by name, and then the name will be the source DLL file name. And I think this also could return error. And then I'll just do a similar thing that I was doing there. We'll just add some error checking. Else we'll do game API modification time equals yeah, the modification time. Okay. And then what we're gonna do down here is that we are going to check if there was a change. So modification time error. And then, yes, I am shadowing, but soon we're going to break this up into a function anyway. And what I mean by shadowing is that I am declaring variables with the same name in a different scope. So the source DLL file name. And then what we're going to do is we're going to say if modification time of, so DLL file changed, not equal to the game API modification time. So if the DLL file changed, reload. And what we're going to do is get a new dest DLL file name. And how we're going to do that is we're going to bump up the version, so API version plus equals 1. And then what we're going to do is similar thing up here. API version. And then we're going to do this copy stuff again. So copy. And yeah, like I said, we're going to do this in a, we're going to extract some of this stuff into a function. So then what we'll do, so failed to copy. So if, what I'm actually going to do is do this. So if there's no copy error, then what we're going to do in here is do the load again. So right here. So we're going to initialize the symbols. And I did mention the thing about needing to load the Raylib library first. So I'm going to do that. So oops, lib dot load library. And then this will be load library and build hot reload Raylib, because that's in there. And that should essentially ensure that that will essentially ensure that any memory that Raylib has ownership of doesn't go like doesn't go out of our process memory address if our game.dll gets unloaded. Because like in initialize symbols, what it seems like it does is if it's an old handle, it will unload the library for you. Okay. So we initialize the symbols, the game API, the dest file name, and let's see. So if new. Okay. And that's what we'll do. And we'll see, there's probably some issues in there, but we will see. Well, what we could also do is Okay. Cool. So let's close that out and let's build it again and see what happens. So build it. Let's go in here and run it. Okay. And let's try modifying something to see if it works. So let's change this green to white. Oops, got some issues. The process cannot access the file because it is being used by another process. So that is the, all right. So what we're going to do at this point is we are going to have to load it into a debugger to understand why it is not working as intended. And because of that, we are going to have to generate a new PDB for it. We're going to have to generate a new PDB for it so that they don't clash in the debugger. So what I'm going to try to do here is get some type of random number. I'm just going to paste in something I pulled off of Stack Overflow. And we'll call it PDB rand num. And then we'll set PDB name equal to where's it equal to? We'll set it equal to the DLL name with the PDB rand num dot PDB. And then down here, we will specify the PDB name, and that will go in the game, sorry, the outdir slash, and then PDB name. And eventually we'll probably put these in their own directory and clear them out, or maybe we'll just clear out the entire build directory if our game is already running. So let's see if that works. Okay, I'm going to close this out, and in Remedy, I'm going to set up a session here. So Tetris edu, and I am going to use this hot reload application, and I'm going to set the working directory to the edu directory because it is referencing things at this path. So let me start debugging. It's white now, but we want to make sure that it's actually getting reset. So get rid of this and open up and this time I'm going to open up the main.hotreload file. And what I'm going to do is put a breakpoint. Oh, am I not building this? So what I also need to do is build the hot reload PDB file. So PDB name, and then we will put it in the outdir, and then just call it main hot reload dot PDB, and let's stop that and build it. Package example. Oh, we don't want that. then the .load library. Okay, let's try to run that again. Okay, we're running, and I think it picked it up. So you know what? I don't even think that was work, like it wasn't even running before. And I think what was happening was I built it while it was already running. So let's go in here and change it to green and see if it works now. Okay, so notice that there was a file change. It's going to step over it, step over it. There was no copy error. It's going to do the load. How many symbols did we get? We got 3, so that's pretty good. And it looks like the load was okay. So let's, oops, the DLL file. Okay, so what we need to do here is we need to remember to set the modification time again. So let's say if load okay, else this stuff. And we'll set game API dot modification time equals the modification time. Build that. Well, we need to build it. And then come back here and do that. And let's see if we could get it now. Okay. That didn't quite work. Completely changed something. How did it do that? Okay, let's go to white. Let's go to the SQ. Okay. So if you're catching that, it is updating this code. I think the reason it's getting set back to 0 is because in the init, so if we go to the init, that is where it sets the active tetramino to be S. But in the global, it just sets it to tetramino. And if you see the first tetramino is an O, so it will get set to that. But, okay, it is creating a lot of those. We don't want that. OMG. Why is that? So it seems that, oh my. Oh, wait, if the modification time changed. Game API modification time. Does this return mode okay? So let's see what's going on there. Real quick, one thing I'm going to change is that I don't need to add a .pdb here, but I'll actually get rid of it there. So I build that. Built hotreload.exe. Let's try. And the game API should run fails because it's not set. Because the game.dll did not get built, I presume. So the game.dll is built. I think something totally terrible happened. Get rid of all that stuff. Guess the game.dll this pdb, exe, and the main.tat. The game API. So the init should run and that all fail. Oh, so what we'll also want to do here, really quick, is that we do want to put this into some type of temp file because it will detect that the modification time changed. um, it will detect that the modification time changed before it's done writing. I don't think that that is the issue here, but I'm still going to do it for now because it will need to get done. And then I think what may have been the problem is that it's getting the last write time of the source still. That's good. Okay. So that's builded. That's builded. Let's run this. Okay, well, let's put a breakpoint right up here and see what's happening. Because my guess is that the load was not okay. So let's add a little bit of a print going on here. So if not load okay, then we want to get the last error and print it out there. Let's build that, run it, and we'll step. So the game modification time got added, and the number of symbols, it got some -1. That's not cool. And what is the error? Can we see right there? Mod not found. The DLL file name is build hot reload game 0.dll. But I see it right there. Oh, I am so dumb. This DLL name should be that and not name. So let's pull that again. And then we get game DLL. So let's try running it now and see what happens. So game 0.dll not found. However, it looks like it was created at 8:17, just like right now. This is not at all what we want to do. We want to see if the outer one doesn't exist. That's the one we want to copy. I don't know what I was thinking, man. Let's build it again. So really, it should have been the output directory with Raylib, but not the other path. Okay. So now if we do that, we're fine. We're fine, dude. Okay. So let's go back here and try to change it and make sure it doesn't continuously loop. So I'm going to change the O to something. Change the O to a red. Okay. Boom, copy, load. Okay. No errors, no errors. Keep going. Okay. We're good. So in here, so if game not running, and let's move this down here. So if game not running, what we want to do, so what we want to do if the game's not running is we just want to completely obliterate what's in the output directory. So let's do that. Let me go here. And let's see if it obliterates it. Yep, it obliterated it because there's other PDBs there. And we could verify if we run it again and we get a different random number there. Yep, so the random number changed. So to my knowledge, that got destroyed and created again. Okay. So the last thing I think for now is you'll notice here when we change, well, let's just put it back to yellow. Okay, so what you'll notice was that it changed from an S to an O because this was getting reset. Hey, so this is me actually a couple days later, which is why I have the wardrobe change. Yeah, I just want to make sure that this video is as good as I could make it without sinking too much time into it. So the last thing we really need to do to implement this correctly is what I had mentioned about the game state in game 1 DLL being some state, and then it needs to reflect in the new state. So really quickly, just to cover what I mean one more time, is that say we move this piece here, and then what we do is we build our game again. So I'm just going to build it again, and all of a sudden our piece is not there anymore, and now it's set to the zeroed value, which is the O, which is yellow. And we want it so that our new DLL carries over the previous state. So how are we going to solve that? We're going to come in here, and what we are going to do is that we're going to take all of this, guys, and I'm just going to move them up here for where I have some of the other struct data type stuff defined. And I am going to make a global struct, which will be the persistent. You know what? Actually, let me just call it what it actually is, which is persistent state. All right, and in this persistent state, we're just going to have a few fields in here like so. And this is going to be all the state that needs to persist between frame runs. So for instance, we don't want to reset the playfield state every frame. We want that to maintain. And that is the type of data that we want to take out of our game 1 DLL and pass into our game 2 DLL, or whatever number that we're working with. So what I'm going to do is I'm just going to name it like this for now. Persistent state. Mostly this to not have to type too much, which isn't a big deal. Like if you want to just name it persistent state, feel free to do that. This is just a personal preference, but also to try to give it a symbol that could be easily searched, so that if I do have to go in and make changes to this, wherever it's like PST dot whatever, that I could easily do that without conflicting with other names of things. Okay, so now what we're going to do is go down to this init here, and then we are going to set PST equal to a new persistent state, and then all of these guys that are getting initialized to something, that's going to get set like so. And let's just verify that that still runs correctly. Well, actually, we're going to have to go in here, and anywhere that we see an error, we are going to then have to add. So let me just go here. This is anytime that the show window as transparent, so pst.show window as transparent, and then we want to get anytime. Okay, and let me run it to make sure we're all good. Okay, we're still all good. And then I think if I rebuild it, let's see if it crashes, because I think it will actually crash. And the reason is because we allocated it with the new keyword here. So that's not going to carry over to the new DLL. So what we want to do is have a function exported here that would be something like get persistent state, and it returns a raw pointer. And then all we want to do is return, or let's just do pointer, raw pointer, and PST, and then return pointer. Did that work? Okay. So we have that function, and then what we want to do is we want a function that I'm going to call just hot reload. And right now it is going to take in a raw pointer type of the persistent state to inject in there. And we'll call this new persistent state. Maybe, I don't know if that naming is entirely correct. And then what we're going to do in here is just set the PST equal to this new persistent state that's going to be casted as a persistent state pointer. New persistent state. Okay, and the reason why I'm just calling this hot reload instead of something like set persistent state is there might be other type of hot reload stuff that's happening in here. So let's say that eventually we're not working with Raylib anymore, or let's say we still are, and we add some shaders. And when we change our shaders, we might need to recompile them on a hot reload. So that is like extra work that we would want to be doing in this hot reload function, as opposed to simply only setting the new persistent state. So that's why that is named that way. So then over here, what we're going to do is add those functions. So get persistent state, and that returns a raw pointer. And then what we're going to do is have one called hot reload proc. And what I'm actually going to do is I'm thinking about renaming this so it's more easily searchable, because I have a lot of places I'm referencing. So I'm just going to call it game hot reload. Game hot reload. And that's only so right now I could search, like, you know, Control Shift F for game hot reload, and then see every place that this identifier is labeled. Then what I'm going to do in here is that on reload, before I initialize the new symbols, what I am going to do is do the old persistent, or let's just say current persistent state, and game API dot get persistent state. That is going to return a raw pointer. And then what's going to happen is it's going to initialize the symbols, and if the load is okay, we're not only going to set the modification time, what we are going to set is the game hot reload. And I forgot that this also needs to take in the new persistent state, is a raw pointer. And then this will get passed in the current persistent state, or maybe I'll call this captured persistent state. And now we'll just see if this works. Like maybe we'll get some errors because I did something wrong, but we will see. So let me build that. Let me close this out. Let me build it again. And let's run this and move that over here. And let's try moving this guy and then rebuild and see if he maintains his position there. Okay, awesome. So he maintained his position. Let's try changing the color of this too. Since the tetramino descriptions are not part of the persistent state, they're just kind of part of some statically defined thing. So let's change the S to, instead of white, let's change it to gold and rebuild it. And he gets updated as gold. Let's change it back to white. He gets updated as white and it maintains his place. Let's place some of these. So I placed one. Let me go back here, change that back to gold. And then come in here, place this again. Okay, we're good. And then I think green is the color that he should be. So let's change it to green and let's place that. And we're good. As you see, this is now persisting as I'm making changes to the code. So the last thing we're going to do here is I have some similar code going on, as you could see, both up here and in here. So what I'm going to do is extract some of this into another function so I have less times that this is actually happening. So what I am going to do is make a function called reload library, and I will just make it get passed in the game API, a pointer to the game API. And I'm calling this reload library because I don't know if that's the best term for it, but it will either load it initially or it will reload it. It'll kind of handle both of those. So what I want to do in here is I'll make the new API version. Yeah, that all looks great to me. So I actually think there is one issue happening here, is that the version captured in the game API, because if we put the version here, then that will technically be 1, but 0 got loaded here. So I think what we'll do is just do the new version here. And let's get rid of that. Let's build that. Okay, built that. Let's come back here and reload it. And if we check in here, okay, so 1, 2. So it's not going to be 0 indexed in here. It'll start at 1, but hey, I think that's okay. Maybe it's not okay, but it looks okay. So let me just get rid of all this commented stuff here. File changed, and we'll do should reload. And this is just for me, like for me to be readable. I like things like this to name things what the actual thing is, and then name it in a sense of how we intend to use it. And then, so let's look this over. So I don't need to get the current working directory anymore. Oh, let me actually change this and verify that that still works. Then let us rebuild it. Okay, that seems like that still works. Did load, we'll change to Raylib did load. Game API reload library, game API init should run render modification time. Source DLL file name, DLL file changed. So we reload the library, which that will initialize it if it was not already initialized. It calls the init, it calls the should run, it calls the update and render. Then what it does is it checks to see the modification time of the source DLL file time. And if it is different than the modification time that we have registered, then we know the DLL file changed. And the DLL file change tells us if we should reload or not. So if we should reload, we capture the persistent state of the game, then we reload it again, and if the load was okay, then we call the hot reload function where we inject the captured persistent state back into the game. And I think after this, I am going to upload some of this code on GitHub so people could start seeing it, because I know that this was a lot. But I hope that this explanation was sufficient for you. And if you have any more questions, I would recommend checking out the Handmade Hero version of this, and then also looking into Carl Zielinski's explanation of this. He has a YouTube video, and he also has a hot reload repository that could be helpful for you. So thank you very much. And I think next time we will get back to the actual game, and I think having it in this way will make some of the development go a lot smoother, where we could easily test changes. All right, thank you.